We have another example on the board. First, we have to find Z total. So we have parallel circuit and just two components, and we have given resistance and capacitive reactance. We can use the product over the sum. So Z total is equal resistance times X of C over R plus X of C, where R is equal 320 ohms times 200 ohms, an angle of negative 90 degrees. Remember, X of C goes always with angle negative 90 degrees, over, open parenthesis, 320 ohms plus 200 ohms, an angle of negative 90 degrees. This is equal 169.6 ohms, an angle of negative 58 degrees. So this is the total impedance of my circuit. Next, I'm supposed to find I total. Okay? So in order to find I total, I'm going to redraw the circuit and show you what I'm doing right now. So this is Z total. Please keep in mind that Z total represents these two components, I mean resistance and capacitor in parallel, okay? So instead of two components, I'm going to simply draw just Z total. So I total is equal voltage source over Z total, where voltage source is equal 72 volts over Z total, which is equal 169.6 ohms, and angle of negative 58 degrees. If I'm going to have voltage in this form, most of the time I'm going to assume that this is RMS voltage. So I have current equals 424.52 milliamps, and angle of 58 degrees. So this is my I total. If I want to find IR, I'm supposed to simply write that IR is equal voltage across the resistor over resistance. But someone is going to say, but voltage across resistor is not given. Voltage across the resistor is given because we have parallel circuit. In parallel circuit, voltage source is equal to VR and is also equal to voltage across the capacitor in this case. Voltages in parallel circuit are always the same. So I have 72 volts over resistance is equal 320 ohms. So my IR is 225 milliamps. This is the value of my current which goes through the resistor. If you want to find the current which goes through the capacitor, so this is VC over X of C, which is equal 72 volts over X of C. X of C is equal 200 ohms, and angle of negative 90 degrees. Don't forget that X of C goes always with angle of negative 90 degrees. So IC is equal 360 milliamps, an angle of 90 degrees. Okay, so this is the current which goes through the capacitor. Next, what am I supposed to do? Someone is going to say, okay, we can find the voltages and capacitance, but I always check my answers. So, because I have found already total current, I'm going to find the total current one more time using KCL, Kirchhoff current law. I total is equal IR plus IC, the sum of the currents which go through the resistor and through the capacitor is supposed to give me total current. So I have IR 225 milliamps plus 360 milliamps, an angle of 90 degrees is equal 424.52 milliamps, an angle of 58 degrees. Please notice that these two values are identical. So we can say that so far we are okay. It means that our values of currents are correct. Next, we have to find voltage across the resistor and voltage across the capacitor. But I already explained that in parallel circuit the voltages are the same. So voltage source is equal VR and is equal VC. So they're equal 72 volts. Next, we're supposed to find the capacitance of the capacitor. So in order to do so, we're supposed to use the formula for capacitive reactance. X of C is equal 1 over 2 pi Fc. We're supposed to solve this formula for C because F is given and X of C is also given. So I'm going to have C equals 1 divided by 2 pi F times X of C, which is equal 1 divided by, open parenthesis, 2 pi times F, which is equal 300 Hertz, times X of C, which is equal 200 ohms. This is equal 2.65 microfarads. Okay, so this is the capacitance of my capacitor. Next, I'm supposed to find the power factor. Power factor is equal cosine of angle theta. Okay, in our case, this is the cosine of the angle which is next to Z total. So I have negative 58 degrees. This is equal 0.529 lead. Okay, I have lead because the sign at the front of my angle is negative, or because the current in the RC circuit is lagging the voltage source by a certain angle. In this case, the voltage is going to lag the current by 58 degrees, or we're supposed to say current is going to lead the voltage by 58 degrees. Next, we're supposed to find the true power. P true is equal I R square times resistance. Someone can ask why we don't have 1/2 over here. because we said that we're going to deal with RMS voltage. This is RMS voltage. That's why our currents are also RMS. And anytime we're calculating the power using RMS values, we don't supposed to put 1/2. So I have IR is equal to 225 milliamps to the second power times resistance, which is equal 320 ohms, and this is equal 16.2 watts. Okay, so this is my true power. Next, I'm supposed to find the reactive power, QC. Let me write over here. QC is equal IC square. Again, I don't write 1/2 because I'm dealing with the RMS values, times X of C, which is equal, IC we found is 360 milliamps raised to the second power times X of C. X of C was given 200 ohms. This is equal 25.92 volt ampere reactive. Next, I'm supposed to find the apparent power. So I have S is equal I total to the second power times Z total, where I total is equal 424.52 milliamps raised to the second power times Z total, which is equal 169.6 ohms. Okay, so this is equal 30.56 VA. And this is the apparent power in my circuit. Now we're supposed to find the series equivalent circuit. So what we're supposed to do, we're supposed to just take the value of Z total, which was equal 169.6 ohms and angle of negative 58 degrees, and convert it to the rectangular form. This is equal 89.87 ohms minus J 143.82 ohms, where the real part is my RS and imaginary part is my X of CS. Okay, so this is my resistance and this is my new capacitive reactance. Next, we're supposed to find the capacitance of my series circuit. So I have again formula for capacitive reactance. X of CS is equal 1 over 2 pi F CS. Rearrange this formula and you're supposed to get CS is equal 1 divided by, open parenthesis, 2 pi F times X of CS, which is equal 1 divided by, open parenthesis, 2 pi times the frequency, 300 Hertz, times X of CS, which is equal 143.82 ohms. This is equal 3.63 microfarads. Now we can draw the circuit. So I have voltage source, which is having the voltage 72 volts, and we can add also frequency. Frequency is equal 300 hertz, and I have resistance, which is equal 89.87 ohms, and I have capacitance C equals 3.68 microfarads. Now I can say that the problem is solved.